Hi all. We are here as a team of 5 to present our analysis on health insurance charges. Let's look at the agenda for the presentation. First, we look at the problem we are trying to solve and the data we use for that. Then we move forward to univariate analysis, which will be presented by Naveen, followed by Dhanavikram, who will walk us through some of the insights from our multivariate analysis. Lastly, we'll have Nidhi and Hariharan presenting us the hypothesis testing and what conclusions we have from that. We'll also look at some of the challenges we had during our analysis. We all know health insurance in the United States is daunting. You never know how much you'll end up charged after a hospital visit. We found that there is a lot of variability in how each individual is charged by these insurance companies. Motivated by this, we wanted to identify the factors that contribute to this variability. Now let's look at the data that we use for our analysis. We collected our data from the GitHub, and the link for it is provided above. We performed some initial data quality checks, like checking for null values, duplicates, and data types. After minimal data cleaning, we ended up with a data set of 1,337 records and 7 features that uniquely identifies a data point. Here is a snapshot of the data. As we can see, there are 3 numerical features and the respective ranges for them: age, BMI, and charges. And then we have 4 categorical features: sex, number of children, whether they are a smoker or not, and what region of the United States they are from. Next, we'll have Naveen, who will be presenting the univariate analysis for us.
Thank you, Indu. For this project, we actually did 2 types of analysis, univariate and multivariate analysis. For the univariate analysis, we examined the counts and distribution of every variable in the dataset separately. We plotted bar plots for categorical variables and histograms for numerical variables. Now let's take a look at the bar plots for categorical variables. Next slide. Yes, the first plot is plotted to check the gender count. In this plot, we can see that the number of males and females in the dataset are approximately equal. The second plot displays the count of smokers and non-smokers. As we can see, there's a huge difference between the two, so much so that the difference of non-smokers are the size of non-smokers is 4 times the size of smokers. The third plot shows the count of patients in different regions. We can see that the patients in the regions of Southwest, Northwest, and Northeast are equal, and the count in Southeast is slightly higher than the 3. And in plot 4, we can see that the most of the patients have no children. Also, the patients having 4 or 5 children are very less, which is very common in today's day and age. Now let's go over the histograms that we plotted. Uh, Taking a look at the histogram of BMI, we can see that the distribution of BMI is normal. Most of the BMIs are centered around the mean, which is 30. Moving on to the histogram of insurance charges, we can clearly see that the distribution is not normal and it is skewed to the right. And we can also gather that most of the patients incur charges up to 15,000 US dollars. Now for multivariate analysis, Dhanavikram will be taking you through.
Thank you, Ravi. Now that we have a solid understanding about the distribution of each and every variable in the dataset, our next step was to analyze the relationship between them and how different variables influence the charges. Moving over to next slide. So first we started off with by analyzing the charge distribution of charges in the context of gender. From the plot, we can see that both the distributions are fairly similar in the up to median. And after that, the males tend to have a wider distribution and higher charges compared to females. And we also brought in region into this context. And to consider all 4 variables, we used a Weiland plot. And from the second plot, we can see even in all the regions, the median value remains fairly similar. And in all regions, males tend to have higher charges compared to female. So moving over to next slide. So another one of our questions was, is there a relationship between the numerical columns BMI and charges, and how would smokers fit into this picture? So to analyze this, we used a scatter plot, and we also found the correlation value between charges and BMI, and we could not find any relationship between the charges and BMI. However, one interesting thing we found out was from the plot, we can see that the smokers generally have higher charges compared to the people who do not smoke. So, with the results of this analysis in our hand, we've started formulating our hypothesis around this, and Nidhi will take over the presentation to talk about this.
Thanks, Dhana Vikram. So now we'll talk about the hypothesis testing. Moving on to the next slide. So here we have defined our hypothesis based on the sample data set that we have used. We have built 4 hypotheses. The first one is the insurance charges for men are greater than those for women. Our second hypothesis is that these charges differ for both smokers and non-smokers. The third variable that we are using is region. Here our hypothesis is that charges are equal across all regions. And our fourth hypothesis is the proportion for smokers is the same for both males and females. Moving on to next slide. So here we'll see that how are we selecting a particular test for our target variable. From this graph, we can see that on y-axis, we have the means of the samples and the x-axis, we have the sample size. From this graph, we can interpret that as the sample size is increasing, the distribution of sample means approaches normality. Hence, we can say that t-test is appropriate as we have a sufficiently large sample size. And the second reason is that the sample mean aligns with the principle of central limit theorem. Moving on to the next slide. So this is our first hypothesis that the insurance charges for men are greater than those for women. For this, we first defined a null hypothesis, which states that charges for both men and women are equal, and our alternate hypothesis that charges of men is greater than that of women. For this, we used a one-tailed, right-tailed two-sample t-test. This test has a rejection region only on the right tail, and the reason why we use this particular test is because of our alternate hypothesis, which states that the charges of men is greater than women. Because of the greater than sign, we went ahead with the right tail test. These are some of our test results. We have taken our critical value as 0.05. Our t-value is 2.1275 and our p-value is 0.0169. So from these results, we can see that the p-value is less than the critical value, and hence we can reject the null hypothesis and accept our alternate hypothesis. Moving on to the next slide. So this is our second hypothesis, where we are seeing that the insurance charges differ for both smokers and non-smokers. So in order to test this particular hypothesis, we defined a null hypothesis as the charges for both smokers and non-smokers are equal, and our alternate hypothesis as charges for both smokers and non-smokers are not equal. For this hypothesis testing, we used a two-tailed two-sample t-test. This particular test has a rejection region on both the sides, that is in both the directions. And this is the exact reason why we used this particular test, because in this particular analysis, we are only interested to see how significantly the insurance charges differs for both smokers and non-smokers. These are some of our test results. We have taken our critical value again as 0.05, and our statistic values are t-value 46.6447 and p-value as very, very small, and it is smaller than critical value. Hence, we can say that we'll reject the null hypothesis and we'll accept the alternate hypothesis. The next hypothesis will be discussed by Hariharan.
Thank you, Nidhi. So moving on to the hypothesis 3, we started with analyzing the insurance charges, whether they were same across all the regions. Since we have 4 regions, Northeast, Northwest, Southeast, and Southwest, we can't be using the t-test and z-test. This is because both these tests can have maximum of 2 samples. So we proceeded with the ANOVA test, and we also checked for the normality and variance condition, whether all the samples are having equal variance using Levin's test. And then we assumed our null hypothesis as charges for all regions are equal, and our alternative hypothesis as charges for all regions are not equal. Once we performed the ANOVA test, these are some of the test results which we got, which is listed in the slide. The p-value is lesser than the critical value, so we rejected the null hypothesis. Next slide, please. Then moving on with the final hypothesis, we decided to find whether the proportion of smokers is same in both the genders, males and females. So since this being both categorical columns, we proceeded with the chi-square test, which is used for testing the categorical columns. So we assume that our null hypothesis as proportion of smokers in male and female are same, and our alternative hypothesis as they were not same. And after completing the chi-square test, the test results are displayed in the slide. We can see that the p-value is lesser than the critical value, so we rejected our null hypothesis. Next slide, please. So what can we conclude from this? After doing multiple analysis, including the univariate analysis, multivariate analysis, and hypothesis testing, we can conclude that males tend to have higher charges than females. And we can also say that charges is not same across all the regions. Some regions have high insurance charges and some regions have low insurance charges. So charges also plays a major role in this. As our final conclusion, we can state that there are some factors like gender, smoking status, and geographical location which affect the how many affect or influence the insurance charges occurred. These trends and insights are for this particular sample, but not for the whole population. If we consider the whole population and do the testings, the trends and insights may or may not be same. Next slide. So now I will be discussing some of the challenges and limitations which we faced during our project. Finding the dataset was really difficult. To phrase it better, finding the dataset which had independent and identically distributed samples was very difficult. If you can't find the dataset with these conditions, then the whole hypothesis framework will fail, which is the main objective of our project. And it was one of the tedious job finding the dataset. Following that, even though we can say that trends from this sample is correct and insights from this sample is some insights, we can't say these are definitive results. That is, we can't say that these are universally correct, because these are not insights and trends from the population data. These are some of the references which we used in the project for hypothesis testing. Yeah, thank you.